BIM, or Building Information Modeling, has been making headlines across the construction industry for some time now. You might have read about it in construction magazines or heard about it during engineering or architecture conferences. Some of you might already be using BIM for your projects. We thought it would be a good idea to make a short video about what exactly building information modeling is, and how it is useful for engineers, architects, and construction professionals. To explain the video, we have used simulations that were kindly provided by the cloud-based simulation provider, SimScale. Let's start with the basics. What exactly is building information modeling, or BIM? In simple terms, BIM is a digital representation of a building's physical and functional properties and characteristics. BIM goes further than just the building's physical appearance and includes information about every component that goes into a project. This helps the designer, whether it's an architect, engineer, or construction professional, to create and design more effectively when compared to other tools on the market today. Every component of a building is essentially a BIM object. This means you could take a window, a door, or an HVAC system as an example, and the file will tell you the product's properties, like thermal performance, its physical characteristics, a graphical representation of what the product actually looks like, product's functional data, allowing the user to manipulate the object the way it was intended to be used. So we can say that BIM is first and foremost a process, but it's much more than that. BIM is a 3D modeling based process that provides architecture, engineering, and construction professionals information and tools to efficiently plan, design, construct, and manage buildings and structures. The essence of the BIM process is that it enables the creation of virtual 3D models that can be explored and manipulated, making it easier to understand the relations between spaces, materials, and systems. A database generates a 3D image and creates building plans. Thus, the BIM process can build, view, and test a structure in 3D. These abilities allow revisions and the assembly of accurate details. The detailed data permits design, clash detection, cost, and scheduling. Each of the stages of design and construction benefit from its involvement in BIM. The most known BIM software solutions are Revit, Navisworks, Autodesk BIM 360, SketchUp, as well as ArchiCAD and Vectorworks Architect. As technology continues to advance, computer-aided engineering, CAE, software is also becoming part of the construction industry. CAE, also called engineering simulation, is being used by engineers and architects to predict wind loads on buildings, ensure pedestrian comfort in urban areas, validate HVAC systems, control air quality and contamination in clean rooms, laboratories, or underground spaces, predict smoke spread, and optimize thermal comfort. Although not usually integrated with BIM software yet, simulation tools are becoming more and more accessible through cloud computing. One example is SimScale, the world's first production-ready software as a service application for engineering simulation. By providing instant access to computational fluid dynamics, or CFD, and finite element analysis, FEA, SimScale has moved high-fidelity physics simulation technology from a complex and cost-prohibitive desktop application only available to experts in large companies to a user-friendly web application accessible to any designer and any engineer in the world via a pay-as-you-go pricing model. Here are a few applications. HVAC system. This video shows the comparison of two ducting designs that were simulated for an inlet velocity of 5 meters per second with the SimScale platform. The blue region on the velocity bar represents the low velocity region, while the red region represents the high velocity region. The first design is an unoptimized one which has sharp angles, while the second design, optimized, is a more curvy one. Pedestrian wind comfort. The Flatiron building in New York generates very strong winds. The building splits Broadway and Fifth Avenue and sits at the end of an open corridor created by Madison Square Park at the north. At this location, winds tend to be very high. In the case shown, the wind flow direction is from the north, but slightly aligned with the Broadway street. This produces the most interesting effects as the flow encounters the unique front shape. The animation kindly provided by SimScale shows the flow speed, where the red color shows the higher flow speeds. In these conditions, the wind gusts reach the front leading edge / cone shape of the building that creates accelerated flow and vortices on the Broadway and especially Fifth Avenue side. Wind loads on buildings. We can see the main effects of the structure optimization in this animation that shows the flow physics at 3 different cross sections along the height. Close to the base height level, the area is the largest, and so is the wake behind the structure. But the corner softening helps to avoid strong vortexes. At mid-height, the cross-sectional area not only decreases, but also changes between symmetric and non-symmetric form. In this animation, a non-symmetric section is highlighted that shows non-coherent vortex shedding. This helps to spread out the frequencies along the height and avoid a single dominant oscillation. At the very top, the wind speeds are the highest, but as the cross-section area is rather small, due to tapering, the forces are thus small also. Combined together, the structure is very well optimized with wind loading and is effective in taming the wind. Let me tell you a little bit about SimScale. From CAD upload to post-processing, the entire simulation process with SimScale happens in a standard web browser. Being cloud-based, the platform eliminates the hurdles that accompany traditional simulation tools, such as high installation costs, licensing fees, deployment of high-performance computing hardware, and required updates and maintenance. With over 150,000 individual users worldwide, SimScale has become an integral part of the design validation process for thousands of successful companies worldwide, such as WSP, Thornton Tomasetti, Arup, L&T, or Acceptance Group. The platform is used by engineers, architects, and designers who want to easily test and optimize their designs early in the design process, thus also reducing the number of physical prototypes required.